Welcome back, guys. Sorry, my pen stopped working on me when I was this video over here, but I think it's working now. Question says, we're going to calculate the limit as x approaches -3 from the right and then from the left of this function over here. So what we need to do I'm just going to factor everything I can. So the top factors to x minus 5, x plus 2. The bottom factors 2, x plus 3, x plus 5. Okay. Now, let's say number -3 from the right. Okay, so that's going to make -2.9999 over here. Well, this number is I'm going to put an approximately equal over here. -2.999 minus 5 is like about -8. -3 plus 2 is -1. -2.99999 plus 3 is a positive number close to 0. And then -3 plus 5 is going to be a 2. Okay, so what we're going to get over here on the top, we have positive 8, because -8 times -1 over a positive number close to 0 is going to equal positive infinity. Okay, now the same thing when I do the limit as x approaches -3 from the left. Well, almost everything's going to be the same. It's still going to be -8. Oops. Sorry, let me write this out again. It's still going to approximately equal a -8 on the top, a -1. But now, if I'm approaching it from the left, it's like -3.000001. It's going to equal a negative number close to 0, and then a positive 2. We're going to have positive over negative equals negative infinity. Okay? So the idea is we're doing this is because we know that -3 is going to be a vertical asymptote. But we want to know, as we approach from the right, the graph is going up. As we approach from the left, the graph is going to be going down. Okay, so vertical asymptotes occur at non-permissible values. Horizontal asymptotes occur as the limit as x approaches infinity equals to some constant c. Okay, the asymptote be y equals c. In other words, if x goes close to infinity, then y goes close to but not equal to some number. So if we want to calculate the horizontal asymptote, we need to go ahead and calculate the limit as x approaches infinity of x squared minus 4x plus 5 over x squared plus 6x plus 8. Now guys, if you remember from way back from our limits unit, the way we do this, if you said x squared is the highest, so 2 is the highest exponent that we have, is degree 2. I'm going to multiply the top and the bottom by 1 over x squared. And what that gives us is the limit as x approaches infinity of 1 minus 4 over x plus 5 over x squared over 1 plus 6 over x plus 8 over x squared. Now, the idea is, as x goes to infinity, these guys all go to 0. Equals 1 minus 0 plus 0 over 1 plus 0 plus 0 equals 1. Okay, so this is telling us that our horizontal asymptote is going to be 1. So I can say, therefore, y equals 1 is horizontal asymptote. Okay, now guys, this is definitely the longer way of doing this question. Okay, well, this is actually the algebraic way of doing this question. Shortcut. If we look at like the coefficients of our term of highest degree, so like this is like a 1 and a 1, this guy's going to come down to like 1 over 1, like we had here, 1 over 1, which is equal to 1. If I look at the shortcut for b, x to the 4th is my highest power over here. So that means my limit, y equals 5 over 3, is the horizontal asymptote for this one. I'm just looking at the highest power of, so it's x to the 4th, 5x to the 4th over 3x to the 4th. This is going to simplify to 5 over 3 is our horizontal asymptote. All right, guys. There are a few not exceptions, guys, to this rule over here, guys, but you're going to come across some kind of weirder examples later on, guys. But we'll cover those ones as they kind of come up. All right, guys. See you in the next video.